Thank you all for being here. I'm sure this is going to be a very, very interesting panel. So I am, as you just heard, I'm the business editor of The Economist. I'm typically in charge of our global corporate coverage, but as is The Economist wont, I used to do different jobs on the paper. And my first job on the paper back in 2010, 2013 was as a science correspondent. And in 2012, in February, I went to Vancouver for the AAAS meeting and actually wrote the leading article in the science section that week, which was about progress in quantum computing. And I remember that was a little bit more than a decade ago. And I remember at the time there was a lot of excitement. This was all just around the corner. And some, wag pointed out that, I think in one of the sessions, pointed out that, just around the corner, just like fusion energy, 25 years away and always will be. 10 years on, some things clearly have changed, and the clearest demonstration that it has is that we're all here at an event called Commercializing Quantum. So something is clearly afoot, and something has changed, and we clearly are closer. It isn't 25 years away anymore. So this panel is an interesting combination of people who are providing the technology and using the technology. And I would like to start with the providers. So maybe Chris and Matt. What has changed? Not necessarily in the last 10 years, but how? Is the technology ready for prime time, or is it still a toy, as we heard? Chris, maybe we'll start with you.
Sure, happy to. Thank you for inviting me to this panel. Happy to be here. So I guess among the words in the title of this discussion is, do I have to start this now? And I guess I started in this field about 25 or 30 years ago, developing the first quantum gate in any platform. But it was a research experiment. It was an atomic clock held together by glue and tape and so forth. And as an atomic physicist, I have to say we're not really learning, I'm going to get in trouble saying this, but we're not learning much about the physics of the atom. That's done. And that's the only quantum part of the devices we make at IonQ. The most important part is done. The physics, there's no breakthroughs needed. It's all about control and engineering. I think our previous speaker, Sarah, mentioned that as well in atomic systems. So indeed, over the last 10 years with Jungsang Kim, who is sort of an engineering counterpart of my science, together we kind of promoted an architecture for scaling. And it did not involve new physics or any breakthroughs. It really involved turning research into a product, into a system that third parties can use. And indeed, that's happening right now. And the IonQ is almost 150 strong, and as I become less relevant to it, that means they're more successful. And so it's use cases. I think I'll turn it over to Matt. We've worked together on a couple of use cases in the domain he knows best, in financial optimization, and this kind of interaction is sort of I think the future of the field as a whole, and also our company in particular.
So Matt, before I turn to you, I mean, it is interesting that obviously the progress in the control aspect has happened clearly, and has there been similar progress on the algorithms, or was that all sorted out as well?
Well, first, Jan, like Chris, I would like to thank you for having QCware here. And by the way, this is a little bit personal for me because my relationship with The Economist goes back to when I was a second lieutenant in the Air Force. Just graduated from a military academy, didn't know anything about the world, and I thought that would be a good educational device. So not meant to be a plug, but it's true. That was a long time ago. In any event,
we take all the plugs we can get.
Okay, but so your kind of fundamental question was what has changed in the last 5 years? One thing that's changed is that the enterprise community, the potential user group, has educated themselves into what types of problems, the mathematical structures of problems that can be potentially run more efficiently on quantum computers. And so what you do have in companies that have any R&D capacity or engineering capacity is they've invested a lot of time into understanding that, because all they care about is this is a new compute resource, it will provide acceleration and better performance to some of my problems, so let me get smart on that. And I think the reason that they've mobilized to such a great extent is they do anticipate, they've seen this they regress backwards, and they've seen the progress that IonQ and other hardware vendors have made, and they derive confidence from that. and they all will take some view on when they think practical quantum advantage will kick off. But certainly this nonlinear acceleration and the amount of attachment or engagement from enterprises speaks to that, their confidence in this. Your other question was on the algorithm side. If you really look at all of the public and private sector investment over the last 20 or 30 years in quantum information, most of it has understandably and rightfully gone into the hardware and device layer. And actually, there's been very little, comparatively little investment on the algorithm side. So there's a lot of catch-up that needs to be done. And we're probably just scratching the surface into the design and build-out of algorithms that will be practically useful in quantum computers. And what's actually quite interesting around that, since we're not necessarily in Europe, but kind of UK, Europe, at least from my perspective, I'm not a scientist, but a lot of the recruiting that we do happens for theorists, for algorithm experts, is over here, not necessarily in the United States. And I don't know if that reflects the historic overinvestment in European universities in more mathematics rather than kind of experimental, but it's definitely true. And so we care a lot about trying to recruit more algorithms experts from over here.
It's very interesting that you say that algorithms have to catch up, because I mean, so far as I can remember, quantum computing basically began with an algorithm. The algorithm was what sort of stoked interest in the first place.
Right.
Sure, right? And then you got the scientists and the engineers trying to harness that, the physics in order to actually perform that algorithm.
Right.
But it was the algorithm that was the initial spark, in a way, for the whole industry. So it's interesting that it sort of seems to have, was stagnating for a while, you seem to be suggesting, and now is catching up.
It does. I don't know if and I'll turn this over. I don't want to dominate this, but it does feel like public and private sector capital works its way up the technology stack, whether it's quantum computing, classical computing, or some other sort of technology. They're kind of saying, let's get the hardware to work, and then we'll worry more about algorithms and software.
So, Brad, I would like to turn to you. I mean, obviously we heard about the fact that enterprise clients are beginning to think about when quantum dominance quantum advantage might happen. How long has LG been investing or looking into quantum as something that will bring future benefits?
Oh yeah, that is a very interesting question. So actually, the LG is the home appliance provider, right? So it's very hard to find some kind of fundamental, complex problem to be solved. But still, we have we are looking for some chance to attack with the quantum computer. So actually, we started 3 years ago. I mean, I didn't know anything about the quantum computing. That is only just the keyword in the fiction story. So, but since then, we have been working hard, and internally, we are trying to a lot of effort for getting some fund internally. But still, there's a very big problem from the kind of CEO and CTO, big hurdles there. But abruptly, there was some event outside, right? Like the Google quantum supremacy that can get a lot of attention from public. So that is very helpful as well. And in 2021, the investment amount for the startup or something like that is increased dramatically, like the $1.7 billion. So there is another one thing we can decide for investing on the quantum computing. So another thing is that by increasing the investment, a lot of talent is entering the quantum technology. But those 3 things are important, but more important thing is that we need to find a very, commercially impact quantum computing algorithm for our internal business unit. So finally, we found one problem, and we can start with our internal fund.
So what is the problem?
That is the kind of multiphysics problem. So like the fluid dynamics and the aerodynamics, they can be applied to the car design, or for example, the air conditioning fan design or something like that. So that is the one example for us.
It's interesting. And Lee, I mean, basically a version of the same question, I suppose. And that is, you know, as we heard earlier today, and as a lot of you probably know, you know, so far, a lot of what current, you know, cutting-edge quantum computers can provide can be replicated or done more quickly and probably, almost certainly, more cheaply or using a classical computer. So at RollsRoyce, what's the rationale for you know, playing with this toy to try and perpetuate that metaphor?
Yeah, I was going to come back on Matt's answer about algorithms. So one of my jobs at Rolls-Royce was I developed and led the team that developed our corporate CFD solver, and that started in Oxford University about 1999. Very good code, absolutely pristine, the perfect code. We brought it in-house. It was another 3 or 4 years before we could actually release that into production. And so, in fact, to your point, just because Shor's algorithm has existed since 1995 doesn't going to mean it's going to, that as it stands, will crack RSA. You know, we always put robust in front of algorithms. So that's our real motivation, is the real values in the software. So we're looking now, you know, to doing algorithms to work today that will probably bear fruit in the second half of the decade. Because that's our experience from classical computing. It takes that long.
But benefits as an actually sort of, you know, practical use of something that you cannot replicate or do more efficiently using classical.
To be proven, I would say. Yeah. There's an interesting paper written in 2015, finite element method, said that the cutoff point between which the theory said the quantum device would be faster than the classical device was 330 million elements. They did an analysis that said that would require 10 to the 25 gates and would take 3 times 10 to the 18 years to run. So, you know, we're in this to sort of prove it, and it's an interesting problem. We're doing CFD as well.
You know, regarding proofs, I mean, the reason Shor's algorithm was the catalyst in the field was that you could prove it. It was actually amazingly elegant 3 lines of math showing that a quantum computer can turn an exponential problem into a polynomial, into an easy problem. The thing is, it's among the hardest problems you could even solve. And the reason we're not hanging our hats on Shor's algorithm is that there will be heuristics out there that will work better on a quantum computer, and you won't be able to prove it. And this drives academics crazy. They have to prove things. So, you know, I think these developments and algorithms may not happen from the academic sector. And I think we're all talking about those things, from differential equations to optimizations and so forth.
Yeah, Matt, I mean, on your sort of client side, you know, you're sort of a client, you know, customer-facing business. Are you seeing more interest from across a variety of sectors now? Has sort of both the number of companies? I'm actually quite curious whether the growth in your, you know, customer base has accelerated, but also, you know, the diversity. I mean, who is coming cap in hand asking for your help?
In general, over the last 3 or 4 years, so not to like pound our chest, but we've signed, at last count, 51 customer contracts. So we have a sample set. It appears sort of the filters are, do you currently use performance computing for something? Do you also have an R&D budget and some longer product life cycles? If you kind of hit on those 2 things, those are prospects. So if you look down at the global kind of Fortune 400 and you filter out hospitality and retail, there's kind of like 150 or 200 companies at this point that have materially invested.
Well, with retail, you would have thought that, you know, the traveling salesman problem is a typical.
Well, but they filter out because of that R&D part, you know. But you're right about that, I guess. But Chris can talk to you more about how that problem gets blown up before it gets reduced. But anyway, it does look like at this point chemistry simulation. So that's pharma materials and petrochemicals. Certainly, these problems have a structure and dynamics that can be fairly naturally or directly simulated on quantum hardware. And then financial services, just because there's this computational power that's applied. And by the way, IonQ and QCware did a lot of work for one customer that's published, Goldman Sachs, and it was specifically on risk pricing, so that sort of exploration. Those 2 sectors, some oil and gas, some aerospace and engineering. You know, groups like RollsRoyce obviously are mobilizing more. But you could cut it that way. The other way to cut it is to look at the problem class. So there's machine learning, optimization, and chemistry simulation. So if these enterprises have those sorts of problems, they see themselves in those kind of problems, they get attracted to study the space more, to invest more.
Chris, on the hardware side, do you have an expectation of when, supremacy will no longer be challenged? Because obviously we have the Google result, but not everybody agrees that this was, that this was genuine supremacy. Do you have is it still 25 years away, or is it more like 7?
Well, my view of the situation is that because the first useful algorithms will be things that you can't easily prove, and it might be that classical computers might be able to do better if they change the way they look at it. These are applications that, at least at IonQ, we're going to scale into them. So the structure of the problems, for instance, that we worked with QCware on for Goldman Sachs, it was executed on a small quantum computer that you could simulate on your laptop. But the way it was executed is not a way that we typically use HPC to do this. Now, as we scale our systems, the structure of the algorithm, the way you program it, the subroutines and the shortcuts, they're all the same. We're just using a bigger system. And then you will challenge HPC, and it will become useful. And so we have a very clear roadmap that's not based on physics breakthroughs, as I said earlier, that in a few years, it's not a decade plus, just in a few years, we'll be able to challenge those things and make commercial value. So we're pretty bullish, partly because our hardware is the most advanced out there.
So Brad, on the applications, so you mentioned one, but are you also expanding the range of applications that you're considering for, to be tackled with quantum, or are you sort of really focusing right now on those which seem to have the shortest time horizon? Or are you thinking about all the different ways in which, or maybe not all the different ways, but various ways in which quantum computing could, in the foreseeable future, so within a decade, say, be of commercial advantage, or are you more focused on the sort of the lowest hanging fruit?
So one thing I want to emphasize is that if we can resolve the differential equation commercially, we can apply a lot of problems. Or, like the physics problem is related with the differential equation. So, which means that if IonQ provide very, like the commercial things in the future, we can resolve a lot of problems. But still, I'm leading a quantum computing working group for the LG group. So there are so many companies like the LG Chemical, LG Display, or something like that, right? They are very interested in the chemical problem as well, like the material discovery and something like that. So, I mean, like it depends on the hardware side and the algorithm side. Those two things are ready. We can have a lot of problems to resolve. So the problem side is not a problem at all. The problem is that the hardware and software algorithm side. That's what I'm thinking right now. So at this moment, I want to ask you if IonQ can deliver the quantum computer on time with their, like the aggressive TRM. So that's what I'm asking Chris at the moment.
So we'll have dinner tonight. We'll talk about the next few years.
Okay.
and Lee, as the same question to you. I mean, are you sort of at the moment really focusing on a specific problem that you think is the lowest hanging fruit, or are you ranging more widely when it comes to potential applications?
So, excuse me. So a bit of both in actual fact. So the thing that we're specifically focusing on, and we have some UK government funding for this, is CFD. So we have 3 years worth of funding on that. That needs fault-tolerant devices, and it's back to my sort of philosophy of it will take us that long to get the algorithms robust. A load of people have talked about hybrid classical quantum today, and one of the things I'm particularly interested in is the classical side of that quantum classical interface. So if you take an algorithm that needs the condition number of your matrix you want to solve, it's almost as hard to find that condition number than it is to solve the matrix classically. And that's a classic operation. Even though the quantum computers don't exist today, we can run the quantum algorithms and we can explore that classical interface. Because I think one of the things that we've got to get used to is quantum computing will drive even more classical supercomputing. Classical supercomputing is going to go up, not down. And then in addition to that, we've got some funding. We're going to launch maybe 3 or 4 short-term projects this year, looking at more nearer-term aspects.
How much do you do in-house and how much do you outsource to people like QCware?
Well, our quantum team doubled recently because we recruited 1 more person. So we sort of got into quantum sort of 2017, 2018. Basically, it was me as the fellow in computational sciences. And so we've built that up. A lot of working with startups, and the Innovate UK program probably took about 2 years gestation period, just talking to people, just seeing what was out there. So I think a big aspect for a big company is working with the startup community. And we're now, as our level of sophistication in-house has risen, we're now looking to sort of place some PhDs. I mean, it's probably taken us 4 to 5 years to get to the point where we know enough about the subject to specify a PhD project.
So my last question, unfortunately we only have a few minutes left, but my last sort of set of questions is about the future of the immediate future of the industry. Obviously we're going through a bit of a tech crunch. A lot of, especially those more speculative technologies, are being very rapidly repriced by the market. I mean, as interest rates rise, the discounted cash flows of the companies whose profits are very far in the future are suddenly look much less appealing. And it would seem that in some ways the quantum industry is a prime example of that, because the profits are probably not in the next 5, even 10 years. They could be very large, but they're probably further out. So I was wondering whether you Chris and Matt, maybe Chris starting with you, whether you're A, experiencing a bit of a chill, and B, sort of expect one, or whether the industry is sort of immune for a variety of interesting reasons.
Well, one surprise over the last year and a half is the demand for hardware, not just cloud services, even cloud services from within our company where we have systems, but they want the real hardware, and we're finding that we're right now spinning up a manufacturing outfit as part of our company, and the challenge, of course, is getting people. We're growing fast, but there's supply chain issues that are unbelievable compared to just a few years ago. Our company, maybe it's a special case. We don't have capital issues. We again, with the transaction going public, we have the runway that we won't have to raise money again. So we're not worried about that side. But supply chain issues are certainly an issue. We worry more generally about this space, especially startups that do need to raise, and that will, I think, affect the whole industry as a whole. But I will say at IonQ, we're not particularly feeling this crunch, and I'll probably get in trouble for saying that.
So, and Matt, I mean, again, we only have a couple of minutes, but sort of, you could sort of either see that long talked about sort of, quantum winter could come as a result of the capital as opposed to the science or the engineering. On the other hand, you could sort of imagine that the strongest men standing will remain, and the industry might consolidate. So you basically be a big winnowing out of the sort of solid, robust companies, which could actually be better for the industry as a whole. Do you have a view on which way that might go?
I have a view. It's one of many views, but I guess history probably repeats itself. I guess in the 1920s there were 200 or 300 automobile companies and probably 200 or 300 aircraft manufacturing companies, and there was a winnowing down. So I guess deservedly and rightly, like IonQ's got this long runway, and they kind of need that because they're building. They need that kind of and thrive on that stability. I think for startups like ours, we really have to, and anyone that are depending on short-term capital markets, capital funding, there definitely is going to be a winnowing down, and investors are going to be focused a lot more on what have you achieved, what milestones did you hit since the last time you raised money, and what are your use of proceeds for this next raise. So that's if you're beholden to capital markets, and most startups are. The other thing we're trying to do at QC, we're very, very hard when we secure customer contracts is to become self-financing. And we're close to that and have been for the last couple of years. So that's the other kind of hedge. But yeah, I do think, in answer to your question, I definitely think that there will be a shakeout. And, you have to deliver. You definitely have to deliver.
Well, from what we've been hearing, and again, the very fact that this conference is taking place seems to suggest that some of the delivery is at least beginning to happen. Unfortunately, we have now run out of time. So thank you very much to the panelists for a very interesting discussion, and hopefully you can accost them later in the couloirs and get more insights. Thank you very much for listening. And thank you.